Okay, so we've started working at starting up the boiler, and for the most part, we have a procedure to follow. But even though we're following our procedure, we can still run into problems. And so the purpose of this video is to talk through some of the common problems that you might run into and how to avoid them. So if we think about our boiler, we have a number of things that are sort of fundamental thoughts about operating a boiler or a steam system that keep us safe. And so some of these things that we want to avoid if we're starting up a boiler would be things like making sure our water level is in a suitable range. So not too high, not too low. We want to be careful not to overpressurize our boiler, so we do have limits to how much pressure is in our boiler. We don't want to heat the boiler too fast. And we want to be careful when we're lighting our flame that we don't create the risk of explosion. Okay, and so we have four really major behaviors that we want to make sure we're avoiding. And avoiding or fixing, if things start to go wrong, all of these things are going to be more important than following our SOP. So these are going to be the kind of overreaching concepts that we have to always be mindful of when we're trying to start up a boiler. And if any of these start to go wrong, we need to prioritize these above anything else. Okay, so what we're going to do is we're going to talk through what causes these and then how we can avoid them as you go through your startup. Okay, so the first one would be water level. And water level's going to be critical in a boiler. So it's what creates steam. So we have to have water in order for our boiler to operate. However, if we have too much water in it, then we run the risk of carrying over to our steam system. So we don't want water droplets moving through our steam system. And if it's too low, then we have an even more dangerous situation, which is that we're going to overheat some of our pressure parts, and they could be damaged because they don't have any water inside of them to cool. So we want to make sure our water levels are within a normal operating range. Ideally, when we're running, what we want to do is keep our water level at a level of 0 or pretty close to it. So we have a normal sort of operating point within our boiler. And to do that, we would balance how much water is coming in, so how much water we're pumping in, with how much steam is leaving. And if we can find the balance between the water that leaves as steam and the feed water coming in, we should have a fairly level or constant level. And we're going to use a main pump and a level controller to do this. And that would be during normal operation. When we go into a startup situation, we don't have the same conditions. We don't have any steam that we're producing, and we don't have any feed water that's going in. So the level controller really doesn't have any use to us. So when we start up our boiler, we can't rely on that controller to function for us the way we expect it to. And so what we do in this case is we're going to use the feed water pump manually to add water into the boiler. Okay, so we do that in step 1, we add water to the boiler. But we don't switch it over into automatic operation. So if we were to add water to our boiler, what we would want to do is, first of all, we want to adjust our level controller. So wherever it's set to, what we want to do is make sure that it has been set to manual and about 20% open. Okay, and that's adjusting this valve position. So this valve would be about 20% open. So that gives us some control over how much water is moving into the boiler. We also want to make sure we've opened up the pathway into the boiler, and that would be the main feed water discharge valve. And then in order to drive the water level up, we're going to turn on the main feed water pump. And we'll monitor our level. And once our level has reached maybe about -50, then it would be an appropriate time to turn off our pump. Okay, and we'll leave the system, everything else as is. So still in manual at 20% and with our valve open. This means that when we need to add water, or if we ever need to add water again manually, all we have to do is turn on our pump in order to add water. It's all ready to go. Okay, so let's talk about the reasons why we might have a low water level. So the two most common cases where we have low water is number one, right at the very start. So the boiler may have too much water, may not have enough water in the boiler. And so typically we would want to add some water at the very start. Okay, so we'll need to fill the boiler to raise the water level at the start. The other reason why we may have low water level is that we've consumed some steam. So as we produce steam, that takes away some of the water that we have in the boiler. And so over time, as we vent steam or use steam in our system, it's going to be taken away from the boiler. And so we would expect over time our water level should drop. Okay. The scenario that you're running, you don't have a very high steam consumption, so it's unlikely that you're going to run too low of water in the boiler. However, you always need to be aware of where is my water level as you're going through your SOP, and it's a good thing to check on an ongoing basis, is my water level within a reasonable range. Okay. And you might consider that reasonable range to be about plus or minus 100 in terms of your water level. If you're getting anywhere close to that, you may need to make some adjustments. Okay, so just as a summary, low water level, your limit, negative 100 while the boiler flame is on. So we don't want to damage any pressure parts by having too low of water level. Okay. Your two common causes, not adding water at the start of the procedure, or larger quantity of steam that's consumed than a normal operation. And that might be because you've forgotten to close a vent, or it took you longer to close some vents, or you were using excess steam in other places. Okay, and that could be a case of your scenario was longer than you were expecting it to go. So a couple of solutions. One, fill the boiler before your startup. And two, check your water level on an ongoing basis once you start to make steam. And if you do need to add water, we know we can just turn on the main feed water pump, add some water in, and then turn it off. So we always have that process that we can go through. Okay. And common error precursors for this, number one, if you forgot to close a steam-related valve. So you find a valve that was left open, oh, I forgot to close that vent or something, that may have an impact on your water level, and you should think about going and checking your water level. Okay. Or I couldn't figure out how to do this, I forgot how to do this part of the procedure, and it took me a long time to think about it and run. If your scenario is taking longer than expected, that may lead to you losing water out of your boiler. Okay. So those two things, if they happen to you, trigger that you should take a look at your water level. Okay. So next we have high water level. And high water level is typically found from three different operating situations. Okay. So the first one is pretty natural actually, and it happens in this boiler. As the water gets heated, it tends to expand in volume. And when it expands in volume, the only space that it can move into is the upper portion of the drum. So this boiler, as the water warms up, the natural movement of water as it expands is upwards. So we typically have a natural case where the water level will tend to rise as we warm up this boiler. And you may notice that during your startup. So that is totally normal. The abnormal cases would be one, overfilling when we're manually pumping feed water into the boiler. So that may happen that you turned on the pump and you were filling and you forgot to turn it off. Okay. Please note the feed water pump, nothing controls it other than you. It is 100% manually turned on and off. There is nothing that will automatically turn it off when the level is good. So you are 100% in charge of that, which means if your water level gets too high because you overfilled it, you are 100% at fault. The other error is often using the wrong feed water pump. So the auxiliary pump has a significantly higher pumping capacity, which means you can overfill your boiler very, very quickly if you're using the auxiliary pump. So stick to the main feed water pump. And then the last one, and we'll talk about that, is overfilling when using the auto level controller at the end of the exercise. Okay, so there can be some errors that happen at that point of the procedure. Okay, so number one, if we consider the one problem would be swelling of our fluid. Okay, and how we can solve that is just knowing that this fluid is going to rise. My level's naturally going to rise. And so in order to prevent that becoming a problem, we're going to underfill our boiler a little bit at the start. So instead of putting it up to 0, I tend to suggest let's underfill it a little bit, maybe somewhere in between -50 and 0, in order to allow for expansion room during the warm-up. The other one that happens is towards the end of the procedure when we're switching over to an autocontroller. And the autocontroller really works well when it has to make small adjustments. But if we have to make large adjustments so that valve is not positioned in an appropriate spot, then it is going to have a chance of overfilling. Okay, here's a situation where we can run into that. The pink line here is our valve position, and if it's been left at 100% open and we start our system, so about here I've turned on my pump, and this brown line is my water level and my blue line is my target. Okay, so right now I'm a little bit underfilled in my boiler and I want to bring up my boiler water level close to 0. Well, we can see that the controller is adjusting the valve position once it's engaged, but it takes a long time to do that. And every second that goes by, we pump more water into the boiler, to the point where we've accidentally overfilled it. Eventually, this might level off and the level might drop, but we're at a significant risk of damage if we get too high with our water level. Okay, so the key thing is that we want to get our valve position close to our normal operating point, which is going to be down low, so a very small percentage. So the best practice is to make sure that the valve is set into a near closed position before we turn on our pump and setting the level controller to auto. Okay, and that happens towards the end of your scenario. Okay, so to summarize our high water level number 2, the cause is going to be overfilling when we're switching to automatic level control. Okay, so the main solution, ensure your level control valve is not fully open when transitioning to automatic level controls. Okay, so we want to make sure we follow that step to manually close the valve before engaging the automatic level control and turning on the pump. Okay, there is one other error precursor that happens, which is you're running through your steps to put your controller into auto and you've forgotten something. So you forgot to turn on the pump, or maybe you forgot to turn on the valve that leads to the boiler, that discharge valve, and you let it run for a little bit and then you realized your error. Common decision making that happens at that point is, oh, turn the pump on, I forgot to turn that on, that's why my level is low. Okay. Or open that valve, I forgot it. But we got a problem. That's going to be an issue. It will easily lead to overfilling the boiler because your automatic controller didn't start from a manual closed position. It's already made adjustments. So if we ever come into the case where our water level is low and we've realized that we had a problem, we want to make sure we go back and start those steps again right from the start so that we follow that process. They're all important for getting our water level to adjust correctly. And so be careful on that. If you ever see something wrong with your water level at the end or you miss a step, make sure you go back and repeat all of those water-related steps at the end. One other one that's very common is overpressurization of our boiler. And our boiler can be overpressurized quite easily in this scenario. If we think about what pressure is in a boiler, it's just really an indication of how much energy is stored. And we can affect the amount of energy stored by either adding or removing energy. And we add energy in the form of fuel that gets burned and produces heat. And we remove energy when we have steam that's leaving. And so when we have our boiler normally operating, we should have a balance between the energy going in and the steam leaving, which maintains a certain pressure. But during startup, we want to pressurize our boiler. So that means we're adding more heat than the steam that's leaving. And the result of that is that our pressure is going to rise. So during normal operation, we try to match these things, and we have controllers that do that for us. So we work at getting the master controller and the burner management system running in this scenario, and they are in charge of trying to balance the pressure in the boiler and keep it within a normal operating range. But when we're not producing much steam during startup, all of the energy that we put into the boiler goes to raising the pressure. And once we've got to the boiling point, your pressure can rise quite quickly. So it's always important to keep an eye on your boiler pressure. And if it rises to our normal operating point or anywhere above, we've got a problem. And so if it rises up to 7 bar, which is our normal operating point, or even before it, the best course of action is to remove the source of energy. So let's stop adding energy to it, and we would just turn off our burner. Okay, so that's the number one thing. If we ever see our pressure going up, we want to stop adding energy to the system. So our normal operating limit, 7 bar of pressure in our boiler. And we have a few reasons why our boiler may spike in pressure. 1, we have very low steam output. Or 2, the flame is not automatically controlled. And either of those can result in us having a pressure that starts rising. If we have a high pressure situation, yeah, we want to reduce the flame output, but probably even better, let's turn off the burner and make sure we've stopped adding energy. And we want to, in the end, make sure our burner controls are automated. There's a couple of common error precursors for these that I've seen. One is you get distracted by other instructions and time goes by. And every minute that goes by, we add additional pressure to the boiler. So that always happens. We always keep adding pressure to the boiler during that startup. So if you're ever caught and you're distracted by one of your instructions, or I'm not sure, or I got to think about this, always think, I better make sure my pressure is okay and monitor it while I'm thinking, and know if it gets too high, I'm going to turn off my flame. You can always restart your flame by going back and restarting your purge process, restarting, turning down your combustion conditions, and getting yourself back up and running. But it's very hard to recover from a boiler that has exploded because you've overpressurized it. The other precursor that can happen is that you forget to reset your speed ratio back to 1. So if you're using the speed ratio to accelerate time during the warm-up, you can easily overpressurize your boiler because the time goes by so quickly. We also have an issue with when we heat up our boiler too fast. So if we heat up our boiler too fast, we can cause stresses in our boiler, so thermal stresses, as different sections expand at different rates than others. And ideally, we want to heat our boiler at a consistent rate. And the rate that we warm up the boiler is really controlled by how much oil we're putting into the boiler. So the rate of oil, or our oil flow controller set point, is going to dictate how much heat goes into the boiler. And we can adjust that from 0 to 100%. In our instructions, we were aiming for 30 to 40 or 60 minutes of warm-up time, and that meant we had an oil flow rate of approximately 4%. If we have a oil flow rate of more than 4% for an extended time, we will heat too fast. So you start out with your burner at 10 and 10, okay, and you're asked to switch over to 1 and 4. However, there are some issues in the instructions which may be confusing in terms of when do we switch that. But we want to switch that as soon as we have an established flame, so that we've started our flame, and then we want to turn back our combustion set points to a lower flame for the longest amount of time possible. The other area that we could make a mistake is not having our combustion controllers in manual during the startup. And if we don't have them in manual, then sometimes the automatic controllers can cause spikes in the oil output. All right, so we want to make sure we're doing this in manual operation, so that we can manually control how much oil is going into that flame. So just as a summary, the warm-up ends up being faster than 30 minutes. And that's caused by not setting your air-fuel ratios to a 1:4 ratio in a reasonable amount of time. And the solution, ensure that the flame output is reduced before continuing with the extended warm-up period. And your error precursors for that: misreading the instructions, or I'll say poor written instructions from the manual. So that caused some confusion. As well, if you're adjusting the time ratio, you do that before you've set the air-fuel ratios, so that a lot of time has ticked by while you're adjusting the air-fuel ratios. So you want to make sure that you've set to 1 and 4 before speeding up time. Okay. So our last one that we talk about in terms of an issue that can come up during this startup is a furnace explosion. So anytime we start a boiler, there's a risk of a furnace explosion on the combustion or the fire side of that boiler. And it's caused by any unburnt fuel that's in the boiler that is vaporized and happens to mix with oxygen and creates an explosive mixture. And as soon as we try to light that pilot light, or we start that flame, then it can cause an explosion inside of that furnace with all of that explosive mixture becoming flammable. So the only way we can be, I guess, pretty much 100% sure that the furnace is free of fuel is to complete a purge. And when we purge, we're going to blow air through. Okay. And we need to be 100% sure that a purge has been completed before we hit the burner 1 on-off button. Okay. This button is really, really dangerous. You always should have caution before turning the burner 1 on. There's no room for error. if you hit this button, there's no going back. It's automatically going to light that pilot immediately. And if there is the risk of explosion inside the boiler, then there's a very good chance you'll have a furnace explosion. So be very careful. This button is extremely dangerous. All right. You should only hit it if you're 100% sure that a purge has been completed. So let's talk about where you may have issues with your purge. So where would it be dangerous where you hit that on-off button and you think you've purged, or maybe you're not sure if the purge has gone through, or you're struggling with some of the purge issues. Okay, so I think there's 4 reasons why your purge might be unsuccessful. First one, the fan is not on. Okay, so you need the fan to push air through in order to complete your purge. Sometimes if you don't have your fan on, then your purge may take an abnormally long amount of time, to the point where you're not sure if it has completed or not because nothing is changing. Number 2, you don't have your airflow controller in manual and at 100%. Okay, so you need to have maximum airflow in order to have the maximum effectiveness of your purge. And if you don't have your airflow set to manual, you can't adjust it. And if it's not set to 100%, it's going to take a long time to complete your purge. So make sure it's in manual and 100%. If there's a trip showing on your burner or your boiler, it may prevent the purge from happening. And then even if you've completed your purge successfully, if you take too long between the purge completion and starting the burner, then there's still the risk of vapors reappearing and mixing to make an explosive mixture. And this may be because 1, you've taken too long, so time has gone by. Or 2, you've been distracted and done some other tasks while you're waiting for your purge to finish. Or after your purge is completed, now I'm going to adjust, this valve or turn on my pump or something. Consider as soon as you do any other action that your purge is no longer successful. You'll need to re-purge. So if we talk about the summary on our furnace explosion, the cause, always 100% of the time, it's hitting this button without a proper purge being done. So that's how a furnace explosion happens, is hitting that on-off button. So be very careful. So solution, never hit that button in any situation to try to turn on the burner unless you are 100% sure a purge has been completed. Now, we also use that button to turn off the flame, and you can safely turn off the flame at any time if it's on, but turning it on from a off position can always trigger a furnace explosion. And there's 2 main places where I see students creating this furnace explosion error. Okay, so number 1, getting distracted during the purge. You should watch the purge the entire time and be confident with the actions that you need to take. So the steps in your SOP, make sure you understand the sequence of the purge, and while the purge is happening, watch it the whole time. It should take probably about 20 to 30 seconds in order to complete the purge. If it's taking much longer than that, go back in your SOP and make sure that you followed all the steps correctly. And then even once that purge is completed, maybe you want to trigger a second purge. You can always do multiple purges. Okay? But number 1, watch your purge and make sure it is done correctly. Don't get distracted by anything else. The purge is critically important. And then number 2, you have a no start condition. So, oh shoot, I forgot to turn on the pump, and that's why my burner 1 didn't go on. Oh, let me hit it again. Never. That button is so important. You should stop and hold your breath and count to 5 and clear your head before hitting that button. Never panic and hit that button. it is so important. You need to be 100% confident that that button is going to be safe to hit before you hit it. This is the most common mistake that students make. Always, always, always be careful with that button. Okay, so I hope that helped out talking through some of the situations that come up in our boiler startup. There's quite a few of them where you can make mistakes, and this is the kind of thing that I'm going to be monitoring on you when you do your boiler startup. Okay, so yes, you have to follow your procedure and get to your endpoint, but you will get deductions if any of these negative things happen. So you have to be balancing both the positive, the SOP as you're working forward and doing these things, but also minimizing any negatives that may come. And the best way to do that is practicing. And if you do make mistakes, you've got this video as a resource to help you while you're practicing to understand what might have done wrong. Okay, good luck with preparation for the assessment on starting up the boiler, and I hope that this video was valuable for you.